As I mentioned in the previous video, a conditional statement is just a new way of providing a given and a conjecture. So, it's a logic statement that has two parts. The first part is your hypothesis, which is your given information, and the second part is your conclusion, which is your conjecture. So the hypothesis is the given, that's what has to be true, and the conclusion is your conjecture, and that's what you're checking to see if it's true or not to determine if your entire conditional statement is true. We're going to use a lot of shorthand when we're dealing with conditional statements. So instead of if something then something, we'll a lot of times abbreviate it to if just the letter P, lowercase p, then Q, lowercase q. Here it says if P then Q. A lot of times we'll even say if P then Q this way, or, and this is the way that I will abbreviate and shorthand this quite a bit, P then Q. P is your hypothesis, and Q is your conclusion. So again, hypothesis is your given information. That's the stuff that you have to make true for sure. The conclusion is your conjecture. That's the thing you're checking. If this is true, can you come up with a counterexample of this situation? That arrow is our then, or implies. So, the first example is just going to be able to pick out our hypothesis and our conclusion. If Mr. Szabo makes dinner, then Mrs. Szabo will do the dishes. Everything that comes after your if, but not including the if, is your hypothesis. So here, we are given that Mr. Szabo makes dinner. Everything after the then, not including then, is your conclusion. So our conclusion or conjecture is that Mrs. Szabo will do the dishes. So just like on the first page, this here on the top is my given, this here on the bottom is my conjecture. Go ahead and try this second one. Press pause, write the hypothesis, write the conclusion. Unpause to check your answer. So the hypothesis is that a CD costs less than $15. The conclusion is that I will buy it. Now, conditional statements are not always given to us in if-then form. Sometimes we have to do the physical rewriting of it to put it in if-then form to be able to identify my conjecture or my hypothesis. So, example, this says all birds have feathers. That's just a statement, but we could convert that into an if-then sentence. If the animal is a bird, comma, then it has feathers. So we're saying that we have a bird, so we're dealing with an animal and it is a bird. Can we come up with an example of one that does not have feathers? If we can't come up with that example, this is true. If we can, it's false. Provide the name of that bird as my counterexample. See if you guys can come up with an if-then statement for all three of the following. Press pause, try to write your if-then statement, unpause to check your answers. So, our three examples, these are my answers. There are slight variations to what we could have, but nothing dramatically different than what I have. We should have something with a hypothesis here of animal being a monkey. So if we're dealing with a monkey, if you have a monkey, something along those lines. But the monkey part needs to be a hypothesis. Conclusion is it has a tail. We do need to include the words if and then. In the second one, if two angles are supplementary, then they are a linear pair. Again, there's not much of a different statement that would work there. Some small differences in wording could be okay. And the last one, if the angle is 90 degrees, then it's a right angle. On this next page, we're going to talk again about truth values and about counterexamples. Since conditional statements are truly just a given and a conjecture like we did on the first page, this stuff is exactly the same as the first page. We're just calling it different or looking at it different because it's provided to us in a conditional form. So the conditional statement is false only when the hypothesis is true, just like when the given has to be true, and the conclusion is false, just like the conjecture would have to be false. And just like with our given and conjecture, in order to show that our conditional statement is false, we have to provide a counterexample. So let's look at a few examples here. If x squared equals 25, then x equals 5. So this is either true or it's false, and we'll have to state that. The only way it's false is if I can come up with a counterexample where the hypothesis is true, but the conclusion is false. In this case, I know this is false because I can come up with an example and I'd want to write this out. I know that x equals -5 is a good counterexample because my hypothesis would be that -5 squared equals 25. That makes my hypothesis true. My x squared is true. But my conclusion, -5, is not true because that's not equal to 5. That makes this a counterexample. See if you can come up with a counterexample or determine if the statement is true for the next two examples. Press pause. When you're done, unpause to check your answers. So both of these examples are false. In the first one, 5 is odd, so it makes my hypothesis true. The number is odd. But it's not divisible by 3, which makes my conclusion false. True hypothesis, false conclusion means the false conditional statement, providing 5 as the counterexample. 7 would be another counterexample, so there's multiple examples in this case. The second one is also false because I can come up with a number, for example 6, which is a multiple of 2, making my hypothesis true, but it is not a multiple of 4, making my conclusion false. True hypothesis, false conclusion means false counter or false conditional statement, making my counterexample 6 in this case. Again, I could have used other counterexamples. I could have used 10. I could have used 14. Lots of different counterexamples. Keep in mind, in this case, all counterexamples have to make your conditional true. It has to be true on your conditional, but then false for your conclusion or your conjecture. On tomorrow's videos, we are going to take a look at rewriting our conditional statements in a couple of different forms and talking about the truth values of the new statements as well.